All right, today we're going to complete Unit 4, Lesson 4. We're kind of finished with our exponent rules for now, and we are going to work our way into looking at exponential functions. And they do look and work differently than linear functions did. So exponential functions are defined by an equation in the form y equals a times b to the x power. If b is greater than 1, if b is greater than 1, so this value right here, if it's greater than 1, let me put the b, then we have exponential growth. And the function is increasing. On the opposite side of that, if b is less than 1, then we have exponential decay. Okay, think about, gosh, one of those CSI shows. If a body is decaying, it is becoming less and less and less likely to see who that person is, right? So if it's decaying, it's decreasing in quality. Okay. In our next unit, we're going to really look at some examples of exponential growth and exponential decay. But today, our task is really all about understanding the equations of exponential functions, creating tables, looking at graphs, and then answering some questions, okay? Now, we will also be learning today about horizontal asymptotes. And that is how you say that word. It's an asymptote, okay? And it is a line which the graph gets close and close and closer to, but it will never ever touch that line or cross it. It's kind of like this invisible boundary point for a line, okay? And everything that we do today is going to consist of 3 steps. Step 1, we're going to make a table. Step 2, we're going to use the table to create a graph. And then step 3, we're going to use that graph to help us answer these questions out here to the right. Okay? Now, some of these questions can be answered prior to actually doing the graph, and we're going to look at that as well. Okay? So, y equals a times b to the x. Let's take this equation number 1, y equals, and let's determine what is the a value and what is the b value. Some of you could probably identify 2 as the b value really, really quickly. Okay, that's the b. But what is the a? There's nothing there in front of it. Well, the a is going to be 1. That's my a value. So to determine growth or decay, I need to look at, is my b value greater than 1 or less than 1? So this b value, 2 is greater than 1. So this is going to be exponential growth, which is right here. We've determined it's going to be growth before we've even looked at the graph. All right. How will we determine the y-intercept? So I want you to remember that the y-intercept is where x equals 0. So let's fill in and create a table, okay? Let's start at 0 here and go both directions. And then we can use a calculator. Actually, I've got some notes to the side here. Okay, step 1 is create a table via substitution or calculator. So you can do this either way. If you want to just do the substitution, let me show you how we would do that. I'm going to do some scratch work here. and I'm going to do it right on my graph. Y equals 2 to the x power. So if I replace the x with a negative 2, this is where my exponent rules come into play for me. Okay, so I have a negative exponent, which means I need to drop that down. So I would have 1 over 2 to the positive 2 power, which equals 1 over 4. So 1 over 4. Okay, so I'm using my exponent laws here to simplify this by hand. All right, let's do the next one where x equals negative 1. So 2 to the negative 1 power. Again, that's a negative. So I need to move that 2 to the bottom and then make that exponent become positive. So when I simplify that, I get 1/2. 1/2. All right, let's look at my next x value. Y equals 2 to the 0 power. What does anything to the 0 power equal? And the answer is 1. All right. Next, my x value is 2 to the first power, which equals 2. Next, I have y equals 2 to the second power. That's my last x variable. And 2 squared is 4. So I filled in my table using substitution method. Okay, I substituted all the x values from the table into where the x is in the equation. Now I do want to show you on the calculator how you would do this. So on the calculator, okay, on our calculator, what we would do is turn this on. We would go to y equals and then type in this function, y equals 2 to the x power. So use this little caret button here and raise it up, and the x button is next to the green alpha. Y equals 2 to the x power. And then I'm going to hit second graph, and that pulls up the table for me. Now you can see in the table on the calculator that it gives me my y values in decimal form. All right, so either way is fine. 0.25 and 1 divided by 4 equal the same value. All right, so you could have filled in your table using the calculator. All right, so now let's move on to step 2. So I'm going to come to the bottom. Step 2 is plot the points and graph each line. So I'm going to plot all of these points. So I'm going to start at my origin. X is -2 and y is about a quarter of the way up. It's rough. So x is -2 and y is a quarter, and that's kind of a rough estimate, okay? Go -1 and y is a half. At x equals 0, y is 1. At x equals 1, y is 2. And at x equals 2, y is 4. And so let me show you what this graph is going to look like. It's going to look something like that. All right. So this is a growth model because from left to right, it is going up, up. And that's how I can tell by looking at the picture that it's growth. All right. Now I want to talk about this vertical asymptote. I'm sorry, this horizontal asymptote. If you look at this graph, it is getting super duper duper close to this line right here, but it is never going to touch that line or cross it. It's kind of that space where this line starts to level out here on the left. You can see it's leveling out. Okay. So my asymptote is on the line. So it's the y-axis at 0. That's how we determine our y-axis. Our y-intercept, you can get that from the table. It's 0, 1. All right, 0, 1. And then let's talk about domain and range, okay? Domain is our possible x values. So just a reminder, these are our x values. Range is going to be our y values. So if we can picture this line going in both directions forever and ever, left forever and right forever, because there's arrows in both directions, that's going to go to positive infinity, and that's going to go to negative infinity on the x-axis. So my domain is, we're going to say, all real numbers. Every single possible x value in the world is covered by this equation. What about the range values? Okay, so the range is my y values. Is there a restriction on how far up and down my graph can go? So remember, range is up and down. The y values go up and down. And the answer is yes. Okay, the horizontal asymptote will help me determine my range. So the range is going to be all numbers greater than the asymptote value. So y's are going to be all greater than 0. Okay, and that's everything that I need to do for a single problem. I did step 1, which is to create the table. I did step 2, which is to plot the points and graph it. And then step 3 is filling in these 5 pieces of information: growth or decay, domain or range, y-intercept, and the asymptote. Let's look at example number 2 together. Okay, so I'm going to kind of show these notes here as well for us. We are going to start out first by creating the table. So I'm going to use my calculator to help me with this. Go to y equals, and I want to clear this out. And I have a new equation to type. So I'm going to do parentheses, 1 divided by 4, close parentheses, raise this using that caret button to the x power. And now I will hit second graph. All right. So here is the values that I can use to type into my table. So we're going to do -2, -1, 0, 1, and 2. So at -2, I'm at 16. Let's go plot that point. -2 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, it's going to be way up there somewhere. Okay. -1 up 4. So -1 up 1, 2, 3, 4. 0 is at 1. So x is 0, y is 1. X is 1. Y is 0.25 or a quarter. Okay, so whoops, it's, I don't know, down there somewhere. 2 is even smaller, 0.625. So it's going to be even smaller. And 3 would be even smaller. And 4 would be even smaller. Okay, but it's so teeny tiny, I can't accurately do that very well by hand. Okay, so now let's connect our points. And I did kind of a poor job at that, but okay, so this is roughly what my graph is going to look like. Alrighty, so let's try to determine if this model is growth or decay. Remember, thinking right to left. Sorry, I said that totally backwards. Thinking left to right, okay, which direction is it going? Or you could look at the b value, okay? Y equals, my a is 1 times b is 1/4. That's the b. And that b is less than 1, okay? So the b is less than 1, so that indicates decay. But also from left to right, this graph is going down. So that also tells me decay. Okay, let's think about where might our asymptote be? Where's our asymptote? Where is the horizontal line that we're getting closer and closer and closer to it never crossing? Okay, and again, that asymptote is right here. So that is at y equals 0. Okay, and so for my range, I know that y is going to have to be greater than 0 because notice that all your ordered pairs that you plotted are above that asymptote line. So that's how I know greater. My domain are my x's. And if I think from left to right, this arrow tells me it's going to the positive numbers to infinity. And then this is going to keep going out this direction in the negative direction for infinity. It's never going to stop. So again, it's going to be all real numbers. And that's pretty typical for our exponential functions. Okay, usually our range, or really in all cases, our domain is going to be all real numbers, and our range depends on where is our asymptote. Last thing I wanted to do was find my y-intercept. You can do that from the table, or you can do that from the graph, 0, 1. Great job. So we've now seen an example of exponential growth and exponential decay. Okay, let's come over to the other side of our paper. And I do have some notes here for number 3 that I want you to just take a moment and jot down. So when there is a number, in the back, okay, I see my A value is 1 and my B value is 3. And then there's this extra number being added or subtracted. It is going to cause a shift and give us a new y-intercept. All right, so I can see here that the A value is 1. So I marked that here, A equals 1. And then my shift is going to be -1 because that's the sign in front of it. So the shift is -1. So what I do is A plus or minus whatever that sign is, the shift. So in this case, it's A, which is 1 minus 1 is 0. So our new y-intercept is going to be 0, 0. And I can tell you that just by looking at the equation. All right, so that's just kind of a hint when we're looking at these equations that they do give us some information. All right. Now, what if I were to look at the table instead? So let's pull up our graphing calculator and go to y equals and clear that out. And let's type in our new equation. So 3 caret x. I'm going to tab over to the right one to come back down from the exponent and then type minus 1. And now I'm going to do second graph, which is going to bring me to the table. And if I scroll down, you can see right there that the y-intercept is at 0, 0. All right. I just wanted to kind of explain to you why that is. Now let's go ahead and fill in our table. Okay, so I'm going to go ahead and plot my points as well. So when x is -2, y is -0.889, which is here somewhere. Okay. All right. When it is -1, this is at -0.6 forever. It's okay. 0, 0, and then 1, 2, and then 2, 8. Okay, so this is what this function is looking like. Great job. All right, so I went ahead and replotted my points really quick. I did not account for the -0.8 and the -0.6. I plotted them above the x-axis, and it should have been below. Okay, so now that this is graphed correctly, now go ahead and identify your 4 pieces of missing information out to the right. Alrighty, so I have filled in all the information out to the right. It should have been pretty easy, but this time notice that the asymptote is below the x-axis, one spot. So the range is going to be greater than or equal to -1 because that's where the asymptote line is. Great job. Let's do number 4 together, okay? And then actually, I want you to try number 4 on your own. Let's try number 4 and then we'll do number 5 together because this will be the first one that we do where the a value is not equal to 1. Okay, so we'll do this one together. I want you to do number 4 on your own. So pause the video. All right, welcome back. This is my number 4. Now I showed um, that the y-intercept, I could have figured it out over here on the left. My a value in the front here equals 1, and then my vertical shift in the back is a +4. So 1 plus 4 gave me 5, and that is where my y-intercept ended up. I also found it from the table in the calculator, and so my y-intercept is 0, 5. And of course, you can see it right here in the picture. Okay. All right, my asymptote is at y equals 4. You can see right here where all these black little points are getting closer and closer and closer to 4. You could even see that in the calculator. So if I were to type this in my calculator, I would have 1/3, whoops, okay, so you can even see in the calculator, if I typed in this equation and then I went to the table, let's scroll down. I want you to look at these x values right here and notice how they're getting bigger and bigger. But then look at these y values. What is happening in these y values? Okay, they approach 4, but they're never actually going to really touch 4. They're just so many teeny little decimals. Okay, as far as I go, it's always going to be just that 4 there. So that is my asymptote. Okay. is at 4. So that's another way to find the asymptote using your calculator even. Okay? All right. Let's look at number 5 together. Number 5 has an A value that is less than 1. Okay? And then my B value is a 2. So let's go ahead and we're going to go to our calculator and we're going to see what kind of points we get for this one. So clear this out. All right, parenthesis 1 divided by 4, 2, whoops, nope, times 2 to the x power. Okay, so that is my function. Remember to put fractions in parentheses, always. Then second graph, and we're going to go look at our table. So I want to go find where these numbers start getting crazy small, okay? And what I do, I like to try to find where's the y-intercept. I'll start there, okay? And then I'll do 2 points above the y-intercept and below the y-intercept. And that's usually why I stick with the -2, -1, 0, 1, and 2, because the y-intercept is always in the middle. So in this case, it's 0.25. Notice my A value is 1 over 4, which is the same as 0.25. 1 is 0.5, 2 is 1, this is 0.0625, 0.03125. These numbers are getting really tiny. Let's go see what is the value of x equals 3. I get a 2. And then if it's a 4, I get a 4. Okay, so I'm going to try to plot all these points so that we can get a really good understanding of the picture here. So at -2, it's really tiny. At -1, it's slightly up. At 0, it is at a quarter. Let me make that a little bigger. At 1, it is half. At 2, it is 1. At 3, it is up 2. And then looking at my calculator, when I'm over 4, I'm up 4. If I were to go look here, when I'm at 5, I'm up 8, which is up here. Okay, so I can see that this graph grew a little. It took a little longer to grow than some of the other ones did that we've been looking at. Okay, but it is still growing. It is going up as we work our way to the right. So I definitely know that I have growth. Okay, I definitely know that my domain goes left and right forever. So it's all real numbers. My range, what is happening there? Let's see if we can find the horizontal asymptote. Okay, so I see that it is getting closer and closer and closer to the 0, but it's not going to touch it. So the asymptote is at y equals 0, which means that the range has to be greater than 0. And then my y-intercept, I could have found it here. It's the A value, okay? Or I could have found it here, or I could have found it here. But either way, it is 0, 1 quarter, and the value of that is 0.25. Either way you want to write it. All right, great job. Let's do number 6. This is going to be our very last example today, and this is going to put every single thing that we've done all together. So my A value, let's go ahead and find our y-intercept. Very, very first thing that I do. So the A value is 5, but there is a shift of -3. So I'm going to do 5 minus 3 equals 2. So my y-intercept is going to be at 0, 2. So 0, 2, 0, 2. And I haven't even looked at the picture yet. Okay, my B value. This B value, let me do that. B is less than 1 because it's 1/2. So this is going to be a decay model. Okay. I know that in all of my exponential functions, the domain is going to be all real numbers. Okay. So really the only information that I don't yet know without graphing is the range and the asymptote. Okay. So I'm going to pull up my calculator and type this in here. So I've got 5 parenthesis 1 divided by 2 close parenthesis, whoops, go backwards, times, oh no, that should be to the x power, yes. And then go to the right, minus 3. And now I'm going to hit second graph. And I can see right there, 0, 2, that's my y-intercept. Okay. At 1, I have negative 0.5. So let's start graphing these. At 1, it's negative 0.5, which is right here. At 2, it is negative 0.75. So negative 1.75. At 3, it is negative 2.3 or 2.4. So negative 2 and then a little more. Oh goodness. So I can't quite see where this is like coming out to a straight slope here. So let's just keep going. At 4, it is negative 2.68. So negative 2.68. Okay. At 5, it's negative 2.84. So, okay, I'm kind of starting to see it level out a little bit. Let me go see. At negative 1, it was at 7. So at negative 1, I'm up 7, which is right here. At negative 2, I'm up 17. Wow. That's like way up here somewhere. Okay. Let's see what I am at a positive 6, negative 2.9, and then negative 2.9, negative 2.98, negative 2.99, negative 2.995, 998. So where does it appear as though it's leveling out? And that is at negative 3. I can see that from my table now. So these points are getting lower and lower and lower. So let's go ahead and it will just draw my line. Okay, so we've already determined that our asymptote is right here. So y equals negative 3, which means that my range is going to be numbers above that line. So greater than negative 3. And that's it. Those are all of our notes for today. There is a practice online for you in Google Classroom. So go ahead and get that started now. And until next time.